Research on Alzheimer's disease is becoming more extensive. After devoting decades of research on the sticky amyloid plaques and tangled tau fibers that are hallmarks of Alzheimer's disease, specialists on the brain are now investigating for other probable causes of memory and thinking problems. How can the symptoms of Alzheimer's disease be controlled? Well, this is the current state of our knowledge on Alzheimer's disease. Let's start with what we know about Alzheimer's disease. The quest is on display this week at the Alzheimer's Association International Conference in San Diego, where lectures are being held on topics such as genes, brain damage, clogged arteries, and inflammation. The event is taking place in the San Diego Convention Center. Even more recently, a team of researchers from the University of Washington in Seattle created a very comprehensive map that depicts how Alzheimer's disease affects different types of brain cells. The goal is to aid researchers in developing innovative treatment options. According to Maria Carrillo, the Alzheimer's Association Chief Scientific Officer, plaques and tangles are clearly a feature of Alzheimer's disease. As this study shows, plaques are not necessarily the cause of cell death. Plaques may form when the spaces between neurons get filled with clumps of a protein called beta amyloid. Tangles are made up of a protein known as tau, which are found within neurons. Both proteins have a propensity to accumulate to abnormal amounts in Alzheimer's sufferers' brains. However, their role in the demise of brain cells is not fully known. Carrillo thinks that Alzheimer's research should follow in the footsteps of cancer research, where improved understanding of the disease has led to advancements in treatment. The shift in attitude was prompted by the fact that although a number of experimental treatments were effective at removing amyloid plaques and tau tangles from the brain, they were unable to prevent the disease from progressing. The Food and Drug Administration has approved one amyloid drug, Aduhelm, but the government is still assessing whether or not it is useful to patients. Now, let's go on. Alzheimer's Disease Atlas. The Atlas study is illustrative of how researchers are revising their previous assumptions. According to Dr. C. Dirk Keen, a neuropathologist at the University of Washington, with this study, we're attempting to look at cell vulnerability early in sickness, before patients have plaques and tangles, and before they have cognitive impairment. In order to create the map, Keen and a team of researchers examined more than 1 million cells taken from 84 brains donated by patients who had enrolled in Alzheimer's research programs run by the University of Washington and the Kaiser Permanente Washington Research Institute. These patients had also agreed to have their brains used in the studies. Keen says of the brains, which came from donors at all different stages of disease, that we can detect what's happening from the earliest levels all the way up to the severe sickness. Brains came from various donors at all various stages of disease. The President of the United States, Barack Obama, initiated the government's Brain Initiative in 2013, and the National Institute on Aging is the organization that is providing funding for the research. You need to understand that organ much better than we do, says Ed Lean, a senior scientist at the Allen Institute for Brain Science, which helped analyze the brain tissue. If we want to treat disorders of an enormously complicated cellular organ, you need to understand that organ much better than we do, he says. Therefore, the researchers focused their attention on healthy brain cells for a number of years before turning their attention to Alzheimer's disease. According to Lean, we've established what a normal adult brain looks like, and now that we have that knowledge, we can use that information to search for changes in certain kinds of cells. Finding susceptible brain cells comes next. The researchers presented alterations they detected in more than 100 kinds of cells taken from the cortex, a part of the brain critical for memory and reasoning, at the Alzheimer's conference. One discovery was that neurons that formed connections inside the cortex were considerably more likely to die than those that formed connections with distant sections of the brain. What we're finding is a dramatic influence on brain circuitry, which might very well be the cause of cognitive decline, Lane adds. If this is the case, a medication aimed at protecting those sensitive neurons might avoid the memory and cognitive losses associated with Alzheimer's. The researchers also discovered brain cell growth, which contributes to inflammation. Certain immune cells and a kind of cell that reacts to damage were among them. While neurons are being destroyed, non-neuronal cells are proliferating and changing, Lean explains. The discovery supports the notion that inflammation has a role in Alzheimer's disease and that anti-inflammatory medications may help preserve the brain. The Seattle team expects that other scientists will utilize the Brain Cell Atlas to develop novel Alzheimer's therapies. We've built an open access portal where the whole community can look at this data, Lane explains. They can mine it to accelerate overall development in the field. One reason Kyle Travaglini, a researcher at the Allen Institute, seized the opportunity to work on the Alzheimer's study was to accelerate development. My grandma had Alzheimer's illness while I was just starting college, adds Travaglini, who will obtain his PhD in 2021. According to Travaglini, the Atlas project is intriguing since it's not predicated on a pre-existing notion about what causes Alzheimer's. It's like looking at the same condition everyone else has been looking at, but in a completely new new manner, he explains. What does it imply to describe Alzheimer's as a sleeping virus? We've been working from a lot of documented data that HSV is connected with an elevated risk of Alzheimer's disease in patients, said David Kaplan, Stern Family Professor of Engineering and head of Tufts Department of Biomedical Engineering. Ruth Itzhaki of the University of Oxford, who worked on this research with the Kaplan Group, was among the first to suggest a link between herpes virus and Alzheimer's disease. We knew there was a link between HSV1 and Alzheimer's disease, and others suspected VZV was involved, he stated. What we didn't know was the sequence of events put in motion by the viruses to generate the illness. Right now, we believe we have proof of such incidents. According to the World Health Organization, HSV1, the virus that causes oral herpes, infects 3.7 billion persons under the age of 50. It's normally asymptomatic and rests in nerve cells. When triggered, it may induce nerve and skin irritation, resulting in painful open sores and blisters. The majority of carriers, 1 in every 2 Americans, according to the CDC, will have very few to no symptoms until the virus dies. Varicella-Zoster virus is also fairly prevalent, infecting around 95% of those under the age of 20. Chickenpox characterizes many of these instances. VZV, a herpes virus, may also persist and enter nerve cells before becoming dormant. Later in life, VZV may reactivate and produce shingles, a skin illness marked by blisters and nodules that grow in band-like patterns and can be exceedingly painful, lasting weeks or even months. Shingles affects 1 out of every 3 people at some point in their lives. Only when HSV1 is reactivated to create sores, blisters, and other painful inflammatory disorders is there a relationship between HSV1 and Alzheimer's disease. Finally, how can Alzheimer's be roused? Tufts University researchers employed silk protein and collagen sponges 6 millimeters in size to create ecosystems that resemble the brain. They implanted neural stem cells into sponges, and the cells transformed into neurons capable of cooperating in a network, precisely like neurons in the brain. Some stem cells differentiate into glial cells, which aid in the survival and function of neurons. Researchers discovered that infecting neurons cultured in brain tissue with VZV did not result in the development of tau and beta amyloid, 2 proteins often detected in Alzheimer's patients. The neurons continued to operate normally. The VZV infection activated latent HSV1, causing tau and beta amyloid proteins to increase, slowing neuron activity. According to Carnes, the virus is made up of 2 common viruses that are normally harmless. However, if VZV awakens latent HSV1, there might be an issue. Alzheimer's disease may be connected to other diseases and cause and effect networks, she speculated. If you suffer a head injury, are overweight, or consume a lot of alcohol, HSV may reappear in your brain. More cytokines, or molecules that trigger inflammation, were produced in VZV-infected samples. According to Kaplan, VZV may produce inflammation in the brain, which might activate latent HSV and worsen the inflammation. HS1 activation has been associated with brain inflammation, plaque formation, and neuron and brain function impairment. The VZV vaccination, which prevents chickenpox and shingles, also decreases your chance of dementia. The immunization may reduce viral reactivation, inflammation, and brain damage. The researchers also discovered that VZV and HSV1 might reactivate after a COVID infection, particularly in elderly persons. They advise keeping a lookout for cognitive issues and nerve cell loss in these scenarios. That concludes our show for today. We hope you enjoyed it. Make sure to press the subscribe button on your way out.